Today we're going to be using this to shoot this with lasers until we get this. Stay tuned.
Darling, you send me, I know you send me, darling, you send me, I know you send me, darling, you send me, darling, you send me, I know. Darling, you send me, darling, you send me, darling, you send me, darling, you send me, you send me, you send me, darling, you.
FARO Edge. It's got two little bits on it, blue line scanner, pointless. We'll be using mostly just the blue line scanner, specifically for the front end, and anything else here, just we can collect a bunch of data really quickly. You know, this is in the $20,000 to $40,000 range. What you are getting is this guarantee: 0.029 millimeters single point accuracy and plus or minus 0.041 millimeters volumetric accuracy. It's usually used to qualify certain things that are being made in the manufacturing facility. Tesla uses a couple of these. It gets used a lot in automotive things where you have organic shapes, things you don't necessarily have the CAD for it. You don't have the drawings, or if you're trying to reverse engineer, which is what we're going to be doing here. All right, so I have my software set up. I'm using Polyworks, which is also pretty expensive piece of equipment, piece of software. FARO does have some software that comes packaged with it, but it's pretty difficult to use, and even the FARO guys don't use it themselves. They use Polyworks also. Now, Polyworks has a lot of different tools. They have inspection tools, reverse engineering tools, analysis tools, and imaging tools. Today we're just going to be doing an inspection tool. So we're going to be scanning with the FARO 3D Imager. Actually, no, we are not, because we do not have the 3D Imager. What we have is the line probe. All right, so let's get that scan started. All right, cool. We're gonna be scanning a surface mesh, basically generating a point cloud, which we can then turn into a surface model, like an STL. Resolutions here, standard gets you to 1 millimeter, fine 0.5, extra fine less than 0.5 millimeters. For our needs, we'll just go coarse will be fine for us. So hit start scan. We have full scanner. Now this whole thing articulates on this little 6-axis arm here. Gives you really good freedom of motion. Now it's reading back all the encoders and all of the joints and figuring out what the tip in space, or in our case where the scanner is in space. I know. It yells at you every time there's some issue. They sort of line up to give you that sweet spot. Shh. Let's see. Let's go with this guy. There we go. Doing this one-handed is really difficult, so I'm not going to be doing the whole bike one-handed, because that would be insane, and I'm not an insane person, technically. It just hasn't been we come over, we can see, and sort of scroll around. There is only one side of this model, not the other side, but, you know, we can sort of see, and if we zoom in, you can actually, it's actually rendering as a surface model. I'll show what the point cloud looks like afterwards. I'm gonna go ahead and shut the camera off, use two hands, and get the rest of the scan. Alright, so there's a small problem that we have. We can take a look at the model actually. All of our scan lines, I know someone's going to be shitting on me for not using a screen recorder. Our scan's super broken up. It's sort of because we're trying to scan everything in one piece. So the bracket that's holding all the dials and windshields and sort of the other pieces kind of get in the way. Why don't we just remove it, scan both pieces separately, and then reassemble everything, which isn't too bad of an idea. So we're going to try that out. There is some worry about all these shiny bits. The blue light laser does really well on black parts, but usually matte. Going to try a little trick for that. But first, let's just disassemble everything. I went ahead and finished all the scans of the bike. Took some of the front, back, rear. Back and rear is the same thing. Front, sides, rear. And what I'm doing right now is I loaded all the scans into Polyworks. Each one has its own alignment group. So what that enables me to do is actually start using feature recognition to mesh some of these scans together. So you'll see me pick a couple scans. There's a bunch in there. I'm just hiding and unhiding them just to manage the workspace a little bit better. But here I'm just pulling different points of reference off of two scans that I know match. And then Polyworks has a very powerful back-end mesh analysis tool that will actually self-align the meshes, assuming that the bikes didn't move between scans and things like that. Now the reason why they're so far away is I kept having to move the base of the scanner around the bike. Now there is an option in Polyworks that enables you to set up specific points in space where you can mount the base of the scanner, and you pump those data points into the program, and it automatically stitches everything together for you. I didn't want to deal with measuring out my workspace, especially because we're working in a garage. It's not a controlled environment anyway. But we got through. We had about 6 different scans, one of which was just the cage, which actually isn't showing here. I was only focusing on getting the bike together. But what I'm planning on doing is taking this and converting it into an STL, pulling that into my CAD programs and start looking at some of the issues, seeing how bad those forks are bent, what's broken, and start finding mounting points so that I can start rebuilding the headlight bracket and things like that. It's pretty late right now. It's like almost midnight. We just finished up. I think that we're going to call it a night here. And the next video will be looking at the scans in Fusion 360, seeing what we can do with the STL model there, seeing what we can do with the CAD data, and looking at the workflow there. But for now, I think it's time to wrap up.
push that in.
I think that's